We've already explored 5 planets to visit in 2022. But hold on, I didn't tell you that there are another 5 planets to discover in 2022. And here they are, 5 planets to visit in 2022, part 2. Actually, I had to choose from 2 planets, which are Teegarden B and C. These 2 planets are 12 light years away from us, and since they have a lot of similarities between each other, I had to choose one of them. So I chose Teegarden C, because he's a lot more like Earth. For instance, has a similar radius, and it's only 1 Earth mass, and the conditions are compatible to support liquid water on it. Moreover, it has a rock core and a rocky crust, making it a great candidate to us, and also putting in consideration that it orbits its star in the habitable zone and has an equilibrium temperature of minus 17 degrees Celsius. Sounds like a great news to us. Counterintuitively, it has a thick atmosphere, so it should be warmer than the apparent temperature, which increases the chances of finding life on that surface. Next one is Wolf 1061c, or known as WL 1061c, which is an exoplanet orbiting a red dwarf star known as Wolf 1061, a cold red dwarf star at a distance of 13.8 light years away. This planet was discovered using the HARPS spectrograph. This planet is considered as a super-Earth, as its mass is about 4.3 that of Earth, which will give it the density either near or higher than that of Earth. And it has a temperature of minus 50 degrees Celsius, and that's a little bit higher than Mars. Moreover, this planet is probably tidally locked, which means that a face of the planet will permanently faces the star, while the other one won't, which can result in a great temperature's divergence on both sides of the planet, meaning that a side will be very hot while the other one will be very cold. But the surprise here is that the terminator line that separates the dark side from the bright side could have the potential to support liquid water on its surface, because at that point the temperatures will be a lot more suitable. Heading to Gliese A32c, or GJ832c, which is a 16 light-year away planet that orbits a red dwarf star, and it has a mass of 5.2 that of Earth. Moreover, scientists said that if it had the same density of Earth, it would have had the same radius as the Earth, or smaller. The planet is in the habitable zone of the star, but because of its orbit eccentricity, the equilibrium varies between minus 20 degrees Celsius to minus 40 degrees Celsius. But what makes it very special to us is its exposure to the same solar flux as Earth. However, because of its density, it has a great mass that will make it much more hotter, like Venus. It feels like this planet is uncertain of its capability to support life or not. Our next planet is Gliese 667, or known as HD 156384c, which is a super-Earth exoplanet orbiting its host star in the habitable zone. And as the most of our list, it's a red dwarf. Moreover, it's a part of a triple star system, which is a system with 3 stars orbiting each other. So as you can see, most of the habitable exoplanets usually orbiting red dwarfs, and that's for good reason. Red dwarfs have cool temperatures, and their inactivity as solar flares or radiation, so the planet orbiting that star won't be harmed with the radiation or the solar flares, that it won't be able to support life. This planet has a mass larger than that of Earth, but less than gas giants like Uranus and Neptune. Interestingly, the equilibrium temperatures of about 4.3 degrees Celsius, and its radius is about 1.5 times larger than Earth. Also, this planet is likely tidally locked, so the habitable area would be the terminator line, which separates the dark side that doesn't face the star from the side that always faces the star. But putting in consideration that the case of living on a tidally locked planet wouldn't be the ideal thing to do, because you would barely see a normal hour's schedule, because in this case there will always be a daylight or a sacred night. Yet it has a lot of qualifications to be on this list, but it's not the best option. Finally, we have TRAPPIST-1. This final station is very intriguing because it's not a certain planet, it's a whole system called TRAPPIST-1. Briefly, it's an ultra-cool red dwarf star discovered by numerous observations of the ground-based telescopes, also space telescopes, especially transiting planets and planetesimals, small telescope, shortened to TRAPPIST, which led to the discovery of the 7 temperate planets. The sizes of these planets varies from Mars size to larger than Earth, and they are highly expected to have similar compositions to that of Earth. But just 3 or 4 planets that are located in the habitable zone, which are TRAPPIST-1 D, E, G, and F. This system is about 39 light years away from Earth. Surprisingly, it has the most planets to be located in the habitable zone. But unfortunately, most of the planets are tidally locked due to their close distance from their host star. But a tidally locked planet will not freeze completely if it receives little radiation from its star. So there is a high potential in this system to be our next station, because we're not looking at a certain planet. We're looking at 4 potential planets to support life.